let's look at this example. You've already attempted this on your own, so let's do it together. We have a graphing calculator, and we're just looking for approximations on 0 to 3 pi. So let's go through this. On our y equals menu, we have cosine of x. We also have it equal to 0.45. And we're looking for the x values between negative pi and 3 pi. So I'm going to set my window to be negative pi to 3 pi. I'm going to go every pi as my iteration on the x-axis. I know cosine is bounded by -1 to 1, and 0.45 is also in that interval. I'm also going to check my mode, that I'm in radian mode, and we're good to go. On my graphical representation, I get my beautiful cosine curve from negative pi to 3 pi, and I get 1, 2, 3, 4 graphical intersections, and I can write down those points by calculating or tracing. So I'm going to sketch this graph here so that I have a record of my thinking. I have my cosine curve at a minimum, maximum occurring at 0. I go back down to a minimum, 1 pi, 2 pi, back up to my maximum, back down to my minimum. Alright, let's see if I can think about this and label my axes. Again, I'm thinking about my unit circle. When does the cosine curve? This is cosine of x. Cosine is 1 at 0, so I know this is 0. Cosine is 0 at pi halves. Cosine is -1 at pi. Cosine is 0 again at 3 pi halves. Cosine has a maximum again at 1. So I'm going around the circle, so now we're at 2 pi. We're going to keep going to 2 pi plus pi halves. Finally to 3 pi, which is the end of our interval. Likewise here, we have negative pi halves and we have negative pi. Then I get my graphical intersections, 4 of them, occurring at about a half, right? This is the line y equals 0.45. And let's calculate those intersections. Second, calculate, intersect. First curve, my cosine curve. Second curve, my y equals 0.45. I'm going to put my guess. I'm going to go in order from left to right. I'm going to put my guess right there. So my first value is -1.1. Let's do it again. Second value, +1.1. We have beautiful symmetry. Again, taking a guess, the graphical intersection. Anytime I'm looking for a solution, I'm looking for the x values that make the equation cosine of x equals 0.45 true. What makes this a true statement? Finally, last but not least, selecting my two curves, making a close guess, getting an intersection of 7.387 or 7.39. Beautiful. Nice work, everybody. Let's look at another problem. I'm going to ask you to attempt this again on your own, and we're going to be using some of our knowledge about cosines and inverse cosines. We've solved graphically and with a unit circle. In this final example, let's use our knowledge of inverse cosines. Remember to attempt this first before continuing the video. I'm going to rewrite the equation. 5 times cosine of x plus 2 equals 1. It gives us the interval that bounds x, 0 less than or equal to x less than or equal to 2 pi. So I'm thinking again about my unit circle, and I'm thinking about the values of cosine of x plus 2, 5 times cosine of x plus 2, which give me 1 on one revolution. All right. So I could graph this as a comparison of, right, 5 cosine x plus 2 and 1. Now, when I do that, that helps me get an expectation for what the solutions would be. I like to think graphically because it gives me some intuition. 5 times cosine of x plus 2, enter, equals 1. Not 145, 1. All right, when I think about my window, I'm only concerned with 0 to 2 pi, and I'm going to go every pi halves. And I'm bounded again. I want to know when that equals 1, so I'm not exactly sure what I'm going to see, but I'm going to go, since it's 5 times cosine, it's probably bounded by 5 and negative 5, since my maximum values for cosine are negative 1 and 1. So graphically, I see a shifted cosine curve, shifted 2 units to the left. I'm still in radian mode, and I get a graphical intersection at 2 places. So I should expect, I'm just going to sketch this curve with not much precision. I should expect 2 solutions, right? If this is pi halves, pi, 3 pi halves, 2 pi, somewhere between there. Let's solve it out graphically. Now symbolically. So that's our expectation. Now, solving just like you would solve any other equations, we operate on this equation as 1 unit. I'm going to isolate my x variable by dividing the equation by 5. Now I'm left with cosine of x plus 2 equals 1/5, because 5 divided by 5 is 1. Now I know that cosine inverse of cosine of x equals x. So if x is x plus 2, we can apply that as well. So now let's apply that. So we get cosine inverse of cosine of x plus 2 equals cosine inverse of 1/5. All right, let's keep going. Since this is an identity, we have x plus 2 on the left-hand side of our equation and cosine inverse of 1/5 on the right. We're almost there. Subtracting 2 from both sides of the equation, we get x equals cosine inverse of 1/5 minus 2. We're still in radian mode, so this is our exact answer, but we can find approximate solutions by computing that. So again, I'm in radian mode, so I have cosine inverse of 1/5, cosine inverse of 1/5 minus 2. Negative 6.30. That didn't give me exactly what I was expecting, because I have 2 solutions in the range from 0 to 2 pi. See how the graph really helped us? So those are giving me solutions over here that are not in my expected domain. So I'm going to add 2 pi to those solutions because I know that cosine is periodic every 2 pi. So x equals 5.65 as one solution, but where's my other solution? When we look at this a little bit more carefully, going back to my symbolic solution approach, note that what I should have written the first time around is when we take cosine inverse, we're looking at either the positive or the negative of cosine inverse of that 1/5 value, minus 2. So when I write it that way, let's look at both solutions. So in the positive case, we had cosine inverse of 1/5 minus 2, and we got approximately negative 0.6305, which we noted was not in the interval between 0 and 2 pi. When we look at negative cosine inverse of 1/5 minus 2, negative second cosine inverse 1/5 minus 2, we get negative 3.369 as an approximation. Negative 3.369 or 37, I'll round it to. All right, again, that's not in the interval of 0 to 2 pi. Since we know cosine is periodic, we're going to add 2 pi because we're going to add 2 pi to both of these, and the reasoning is the same. Cosine of x is the same as cosine of x plus 2 pi. Anytime you take a value and add it to 2 pi, you come back to itself. So in this case, our solution, x equals, I'm going to add 2 pi to this second one, right? Plus 2 pi, I get 2.91, and x equals 5.65, which is what I had before. All right, we can check that again using our interpretation. These values look a little bit better, right? Because this looks like it's about 2.91 and 5.65, the x values of those intersection points. We could double check that on our graph if we wanted to. Looking at our graph, I'm going to do a trace, and I'm going to go to 2.91, hit enter, and look, I get right at that intersection point because I'm looking for the relationship between 5 times cosine x plus 2, when is it equal to 1? And then another approximation, I had 5.65 as an approximate solution, and I'm just right about at 1. Nice job. Time for you to attempt some of these problems on your own. Remember all the tools that you have available to you when solving.